Hey, what up, YouTube? Welcome back to Unscripted. Today I saw an interesting ACT problem that I thought would be interesting to solve it out here for anybody who's preparing for the ACT or SAT or just interested in math in general. I think this is an interesting problem um, that should be interesting to solve. So without further ado, let's jump right into it. So this is the question. It says, a 6 foot spruce tree is planted 15 feet from a lighted street light whose lamp is 18 feet above the ground. How many feet long is the shadow of that tree? So we see here the street lamp is here as you, and then its height is 18 feet, and then the spruce tree is also here, which and its height is 6 feet. So typically the way to go about solving these problems would just be to use proportions where um, in other words, I mean, in different cases you'd also use some sort of Pythagorean theorem to try to solve this. A equals b squared, a plus a squared plus b squared is equal to c squared is typically the way you would go about solving these sort of problems if you're given two sides. But in this case, it doesn't look like we're given all the two sides are complete. At least we have the height, but the base isn't quite complete. We know portions of it, so we can't use a squared plus b squared is equal to c squared in this situation. So and likewise, we're also comparing two triangles here, so we can use proportions, right? We take the smaller. We know that the tree that this spruce tree, the triangle that this spruce tree makes here, has a height of 6, and then the street lamp has a height of 18. So we can set it up as a proportions problem equal to, and then so far as we remain consistent, so we'll set it up as equal to the base. We don't quite know what the base, I mean, what the shadow that the spruce tree cast, what the length of that would be, right? So we can use x to represent this then here, the shadow or the length of the shadow that the spruce tree cast. We'll represent that as an x, and since for the height we have the height of the spruce tree in the numerator, likewise we'll have the length that the spruce tree or the shadow that the spruce tree cast, we'll have that on the top or in the numerator. And then we'll look at the base for the shadow that the street lamp cast. We see a 15, part of it is 15. So from the street lamp to the spruce tree, that's 15 feet. And then an additional x, which we still don't know, that the spruce tree cast. So it'll be 15 plus x. And then from here, it's just algebra. We can just solve for this using algebra where we can multiply the numerator here. It'll be just to get rid of the 15 plus x. When we do that, let me put a parentheses around these. When we do that, we can get rid of this and get rid of this. But whatever you do on one side, you have to do on the other side of the equation as well. So we have to multiply the 15 plus x on the left side of the equation. And so simplifying further, let me draw an arrow here. We'll get x is equal to, and then we can distribute this. So this will be 6 over 18 is, we can simplify to be 1/3, just to make the problem easier on ourselves. So 1/3 times 15, I mean, this should be 5. It'll essentially be 15 divided by 3, which would be 5. And then we have this x here, so it'll be plus x over 3. And then from here, like I said, it's just all algebra, right? we can subtract the x over 3 to the right side of the equation. So we could just do that. And then we'll do the same for here as well. And when we do that, this simplifies to 5 is equal to 2/3. And mind you, we still have an x here. So to solve for x, we can just multiply. We can get rid of the 3 denominator. So we can multiply this side by 3 to get rid of the 3 here in the denominator. Do the same on this side as well. And we get 15 back up again is equal to 2x. And then to solve for x, we can just divide both sides of the equation by 2. And we get x is equal to 7/2, or 7.5 in this case. So checking back here, we see that the answer in this case then would be B, 7.5. But yeah, I mean, this I thought was an interesting problem. I thought it'd probably give a few students some challenges in terms of setting this one up. So I took the initiative to solve it, to put it up here for anybody who might be interested. So if you enjoy this content, just make sure to hit the subscribe button, like, share, and come back for more problems like these. I'll see you next time. Thank you for watching. Bye.